Look at your hands. The skin on them is not the same skin you had 10 years ago. The cells that make it up have divided, died, and been replaced thousands of times. The proteins that hold it together have been rebuilt, repaired, and rebuilt again. Your body is in a constant state of maintenance, repairing damage, replacing parts, fighting entropy at the molecular level every second of every day. And it is losing, not dramatically, not all at once, but slowly, inevitably, the maintenance falls behind the damage. The repairs become less precise. The replacements become less perfect. The machinery that keeps you running begins, almost imperceptibly, to run down. The question is why? Not why in the sense of bad luck or design flaw. Why in the evolutionary sense? Why did natural selection, which is ruthlessly efficient at eliminating anything that reduces survival and reproduction, allow aging to exist at all? The answer is older than you can easily imagine, and it is written into your biology in ways that connect you directly to creatures that lived 200 million years ago. Before we go further, we need to be honest about what science knows here and what it doesn't. We know that aging is universal among complex multicellular organisms. We know it involves the accumulation of molecular damage over time, damage to DNA, to proteins, to the membranes of cells. We know that some species age dramatically faster than others, and a small number of organisms appear to age so slowly they are functionally immortal. And we know with reasonable certainty that aging is not a biological accident. It was shaped by evolution. What we do not fully understand is why evolution shaped it this way. There are competing theories, supported by different lines of evidence that give different emphasis to different mechanisms. The honest answer is that aging is probably not one thing. It is probably several things happening simultaneously, interacting with each other in ways we are still working to untangle. To understand why you age, you first have to understand what evolution actually optimizes for. Not longevity, not health, not the well-being of the individual organism. Evolution optimizes for reproduction, for passing genes to the next generation. Everything else is secondary. An organism that reproduces successfully before it falls apart has done everything evolution asked of it. What happens after reproduction is, from the perspective of natural selection, almost irrelevant. This is the key insight that unlocks aging. In the wild, most animals do not die of old age. They die of predation, starvation, disease, accident, external causes that have nothing to do with their internal state. A mouse in the wild lives, on average, less than a year. The probability that any given mouse will survive long enough to experience the effects of aging is vanishingly small. Think about what that means. The genes that cause a mouse to deteriorate at age 3 are effectively invisible to evolution. They never get expressed in the wild. They never get selected against. They just accumulate quietly, passed from generation to generation, doing nothing until the rare individual lives long enough to feel them. Scientists call this mutation accumulation, and it explains why you carry right now genetic baggage that evolution never bothered to clean up. Because your ancestors almost never lived long enough for it to matter. But there is a second mechanism, and this one is darker. Some genes do not just slip through unnoticed. They are actively selected for, favored. Because in youth, they do something useful. They promote growth, accelerate healing, push reproduction. Evolution bets heavily on them because the payoff comes early, when it matters. The cost comes late, when most animals are already dead anyway. Scientists call this antagonistic pleiotropy. The same gene. 2 jobs, one that helps you survive youth, one that slowly dismantles you in old age. The clearest example involves a gene called p53, a tumor suppressor that prevents cancer by triggering cell death when DNA damage is detected. Strong p53 activity protects against cancer, but it also depletes tissues of the stem cells needed to repair and regenerate aging organs. The mice engineered to have extremely strong p53 activity were extraordinarily cancer-resistant, and they aged faster and died younger than normal mice. Your cancer protection and your aging may be the same mechanism, seen from different angles. 200 million years ago, the ancestors of all modern mammals were small, nocturnal, warm-blooded, about the size of a shrew. They moved through the undergrowth at night, while animals the size of buildings walked above them. And they had one evolutionary imperative that overrode everything else: reproduce before something eats you. There was no advantage to living long. There was every advantage to growing fast, breeding early, and burning whatever resources were available right now. Longevity was a luxury that nothing in their environment would ever let them collect. The metabolic rate that warm-blooded mammals require, the internal furnace that lets you maintain body temperature, move fast, think quickly, generates reactive oxygen species as a byproduct. Free radicals that damage DNA, proteins, and cell membranes. The faster the metabolism, the more damage accumulates. Small mammals with high metabolic rates age and die quickly. Larger mammals with slower metabolisms age more slowly. This is the 200-million-year-old answer. The pace of your aging was set by the conditions under which your earliest mammalian ancestors lived. Conditions of intense predation, short life expectancy, and strong selection pressure for fast reproduction over long maintenance. You are not aging because something went wrong. You are aging because something went right. For a shrew-sized creature trying to survive in a world of dinosaurs. And yet some organisms found different solutions. The naked mole rat lives for nearly 40 years, 10 times longer than a mouse of comparable size. It shows almost no increase in mortality risk as it ages. It simply doesn't deteriorate the way it should. A 2025 study published in Science identified one reason. A specific protein in the naked mole rat repairs DNA damage more efficiently than in any other mammal studied. In the same year, researchers at the University of Rochester transferred a longevity gene from naked mole rats into ordinary mice. The mice became healthier. They lived longer. Unique longevity mechanisms that evolved in long-lived species, the researchers wrote, can be exported to improve the lifespans of other mammals. The Greenland shark lives for 400 years. It reaches sexual maturity at around 150, meaning it spends a century and a half as a juvenile before it even begins to reproduce. The ocean quahog clam has been documented at 500 years old, 5 centuries of continuous existence in the same body. And certain jellyfish, when stressed or damaged, can revert entirely to their juvenile state and begin again. Not metaphorically, biologically. The clock resets. These organisms did not escape the logic of evolution. They evolved under different conditions, low predation, stable environments, circumstances where investing in long-term maintenance actually paid reproductive dividends. Their longevity is not a miracle. It is the output of a different optimization run under different constraints. What they reveal is that aging is not inevitable in any absolute biological sense. It is not written into the laws of physics. It is written into the logic of natural selection. And that logic is conditional. Change the conditions, and the output changes. The uncomfortable implication is that aging is not a disease to be cured in the conventional sense. It is not a malfunction. It is the predictable output of an evolutionary optimization that happened under conditions radically different from the ones you now inhabit. You live longer than your genome was designed for. The maintenance systems that kept your ancestors functional long enough to reproduce were never built to last 80 years. You are not aging because you are broken. You are aging because you are the descendant of creatures that survived by burning fast in a world that killed slowly. The next time you notice something in your body that wasn't there before, a gray hair, a joint that aches in the morning, a recovery that takes longer than it used to, you are not experiencing failure. You are experiencing the cost of a trade your ancestors made before mammals had names. And it kept them alive long enough to become you.